Now, when we measure an angle here, we're always going to measure it from the x-axis, this line right here. So this line is known as the initial side. Or the initial position. So if you want to measure like a, let's say a 35-degree angle. You get your protractor handy. So what you're going to do is take your protractor and lay it. Notice the protractor I might have to make this a little bit bigger here because, you know what, get a smaller one for me. Maybe I'll use a smaller protractor. So I don't have to use the whole sheet of paper. I have a little one here. Here's my protractor. I'm gonna lay it on this paper. I gotta make sure they line up, notice. And the way this one reads, it reads both ways. It reads going this way, and it also reads going that way. That's why you see two sets of numbers. Notice when you're traveling this way, that's 0, 10, 20, 30, 40, 50, 60, 70, 80, and there's the 90 degree. So I didn't do a good job with my axes. They're supposed to line up, but I screwed up a little bit there. So if I want to measure, let's say a 33-degree angle, there's the 30, 31, 32, 33. Somewhere here. I can't really pinpoint focus. My eyes can't focus that on that value. But 33 is somewhere right here. So you draw a line, and notice the good thing about this line, the length of the line doesn't matter. That's still 33 angle. This angle here, still 33 degree. And this is a positive. Now this side is known as the terminal side now. That's where we end at. Now let's talk about the angle. Angle is going to be either positive or negative. When you measure an angle, you're going to tell me a positive value or a negative value. Well, when is it positive and when is it negative? If the terminal side is the result of rotating counterclockwise, notice to go from initial side to terminal, you have to go counterclockwise. If it's counterclockwise, it is positive. So when the rotation is counterclockwise. And is negative when the rotation, when you take that terminal side, move it down, that's clockwise. So if I want to graph angle 37, let's say 137 again, I'll take my protractor, lay it over that. This is the 0. There's the 90 degrees. This is the 100, 110, 120, 130, and 137 is somewhere here. A little bit more than 135. Right here. And again, this angle here, you measure from that initial side, that's positive 137 degrees. What about angle negative 45? Where's the negative 45? We gotta go which way? Clockwise, right? To be a negative angle, you have to go clockwise. Where's the negative 45? You gotta turn your protractor upside down. You gotta lay it upside down. 10, 20, 30, 40, I wanna do 45, it's right here. Try to get the reflection out. So you gotta travel, if it's negative, you gotta travel clockwise, and when you draw that line, that's negative 45, negative 45 degree angle. So negative when you travel clockwise, positive counterclockwise. Most of the trig functions are discovered by Greek mathematicians. So a lot of times for angle notation, we use Greek letters. So angle notation, instead of X and Y, we use Greek letters. We use theta. We use alpha. We use beta. We use phi. So we use Greek letters. When people said, "Oh, that's Greek to me," they're not lying. Greek letters. So we use, and to write the angle, we always use that little angle theta. Angle 45 degrees. See, we draw that little symbol, looks like angle. Angle negative 55 degrees. Angle 137 degrees. Angle 33 degrees. Angle negative 45 degree. So a lot of times when we say graph this angle, in physics, Damon will tell you, I use that notation constantly. The other thing to remember is we use also radian. There's two ways to measure, and actually there's three ways: degrees, radian, and gradient. When you look at your calculator, when you go to put it in mode for angles, you'll see there's degrees. This is a cheap calculator, but you can see DEG on the top. And if I can see this, if I can focus on that, I think mode, I can't tell that number. 4, 7, what's that number? 6, 5? That will convert to radian. Can anyone see what it says right there? So that thing is mode 5 or 6. Yep. Notice that's radian. And I think mode, I'll try different modes. 7. Nope. Mode 8. Mode 9. I can't see what that number is. It's radian. I'm looking for a gradient to see what that mode there. I need my magnifying glass to be able to see them there. But you can go degrees, radian, and gradient to measure it. I want to switch it back to degrees And your guess, where's degrees? God. I can't, oh, degree, mode 4, I think. Mode 4, I think it's degree. Nope. Mode 4, degrees, yep. So I can switch on this between degrees and radian there. Well, how do you do them on paper? How do you switch from degrees to radian, radian to degrees? So let's look at this video, this page here. To go from degrees to radian, you need to multiply by pi over 180. And to go from radian to degrees, the reverse, you need to multiply by 180 over pi. I don't have a unit circle here. Do I have one? Sometimes I have a floating around the sheet here that has a unit circle on it. No. Nope, not here. Let me take a peek here. Not here. Oh, here's one. You can find these on the web all the time. Just type in unit circle. So if you want to get one of these, go to the web and type in unit circle. And you'll get tons of these. Some in color if you have a color printer. You can print them. They give you different angles in degrees and in radian. Notice 30 degrees is pi over 6 radian. 45 degrees pi over 4. They also give you the cosine and sine. We'll talk about them shortly. But how do we convert 30 degrees to pi over 6? Well, let's see. I just finished saying to go from degrees to radian, I want to convert that to radian. To go from degrees to radian, multiply by pi over 180. So I got 30 degrees, that's 30 over 1. I'm going to multiply it by pi over 180. And simplify your fraction. You multiply 30 times pi, 30 pi, over 180. To simplify this quickly, there goes the zeros. You're dividing by 10. That's 3 pi over 18. Can you simplify 3 and 18? Can you divide the 3 and 18 by anything? How about a 3? By 3, this is what? 1 by 3, this is 6. That's pi over 6. So 30 degrees is pi over 6. That's what the unit circle is telling me. $90 degrees. How many radian? Again, we go 90 over 1 times pi over 180. That's 90 pi over 180. The 0 cancels the 0 for now. We can simplify more. Can you simplify 918? 1/2, right? Pi over 2. 90 degrees is pi over 2. I'll do another one. 240 degrees. How many radian that is? (240 over 1) times what? Pi over 180. 240 pi over the 180. The zeros cancel each other out. 24 pi over 18. Let's look at 24 and 18. Can we simplify 24 divided by 18? They're both divisible by 6, right? By 6. What's 24 by 6? 4. What's 18 by 6? 3. That's 4 pi over 3. Let's convert backward. Let's go from degrees to radians. We said you gotta multiply I just did degrees to radian, right? I just did that. I want to do radian to degrees, my mistake. Radians to degrees. We just did degrees to radians. To degrees. You're going to multiply by 180 over pi. If I said I have an angle that's 5 pi over 6, can you tell me how many degrees that is? To me, my brain doesn't understand radian. I know degrees, but I don't know radian. I don't know where 5 pi over 6. I don't know if it's first, second, third, or fourth quadrant. I don't know that. So if I take that, I go 5 pi over 6, and I'm going to multiply that by what? 180 over pi. And I can see quickly that the pi will cancel the pi. And while I'm at it, make my life easy. Instead of multiplying these numbers, get a massive number and divide it. Let's simplify. By 6, this is 1. What is 180 by 6? Isn't that a 30? So 5 times 30 is 150 over 1, which is 150 degrees. And I know where the 150 is, more than 90 and less than 180. So I know where that is. Three pi over 2. How many degrees that is? Three pi over 2 times 180 over pi. The pi cancels the pi. Top and bottom you can cancel. The 2 and the 180. By 2 this is 1. By 2 this is 90. What is 3 times 90? 270 divided by 1 is 270 degrees. We use that little circle to indicate that's degrees. You might hear the book talking about coterminal angles. So the book will talk about coterminal angles. What does that mean, coterminal angles? It says any angle or angles that have the same initial and terminal side. Initial and terminal side. So let me draw that. Here we go. One thing I forgot to write on this graph when I did it early, if you're traveling this way, counterclockwise, this is what? The 0 degree. Counterclockwise, when you get to the y-axis, how many degrees that is? $90 degrees, yes, Catherine. 90 degrees. Continue back to the x-axis here. How far did you go? 180 degrees. And if you continue to go, this is what? 270 degrees. And when you stop right there where you started from, that's what? 360 degrees. If you go counterclockwise. So each one of these is 90 degrees. If you travel clockwise, this is the 0 degree. You go in this direction. So this is what? Negative 90. This one is what? Negative 180 degrees. This is what? Negative 270. And back here to negative what? 360. So when we said coterminal angles, these angles have the same initial and, I forgot the word, oh it is here, initial, the same initial and terminal side. So for example, what is the coterminal of 90 degree? 90 degree and what would be coterminal? This is the 90 degree, that's this line. Going this way, 90 degrees. Give me another angle that has the same initial side and terminal side. That's this one going this way. That's the same as what? Negative 270 degrees. So 90 and negative 270 are coterminal. You can get to this side by going 90 degrees this way or by going 270 degrees in the other direction. 180 and 80. And what? Negative 180 are coterminal. They'll have the same starting point, the same initial side, that's this one, and the same terminal side, that's that one. What about if the angle is not like a nice angle like 90 and 270 where you can look at them and go, it's obvious? I'll give you one. I'll give you more than one. Maybe color them. This is one. This is another one here. Let's say the 47-degree angle. What's the coterminal to 47-degree angle? That's this angle. And how do we figure out what that angle is? What is it?
So you add the 90 plus 90 plus 90, and then you take the 90 and subtract 47.
Okay. Is it add 90 plus 90 plus 90 plus 9 and subtract 47? Is that what you said? Or take the 90 plus the 90 plus the 90 and figure out what that angle is and add it. Well, you could do that. Or you can make life easy instead of 90 plus 90 plus 90. If you travel all the way 360 degrees, where do you go? Right here. So subtract from it that angle. So it's actually 360 minus the 47, but you want it to be a negative number. So to make it a negative number, we just change the sign. So we go, it's negative 360 plus the 47, because you're going counterclockwise. And that'll give you the answer negative. So basically it ends up being just subtract 360 degrees from it. So what is negative 360 plus 47? Which is negative 310 degrees. Or can't be 310. 313? 313. That's the coterminal. So negative 313 is coterminal to 47. They both have the same initial side and the same terminal side. 112. I'm guessing 112 is here, more than 90 degrees. This is 112. What is the coterminal of 112? That's if you go this way. So negative 360 plus 112, or just 112 minus 360, any way you want to write it, because you can write that. It's the same thing. And it's negative what? 248 degrees. So negative 248 degrees is coterminal to 112 degrees. If the angle is negative, you don't want to subtract, because if you subtract, you're still getting another negative angle. So if the angle is negative, let's say the angle is negative 22 degrees. That looks like more than 22. How about negative 42 degrees? What's the coterminal of that? You can't subtract negative 360. It still gives you a negative number. So what you want to do in this case is what? Add 360. So it's going to be negative 42 plus 360. 360. I don't need a 318. So 318 is coterminal to negative 42. One has to be positive, one has to be negative. They can't be both positive or both negative. Let's try negative I don't know, 140. What's the coterminal of that? It should say negative 140 plus 360. Is it positive 220? So 220 is the coterminal of negative 110. 318 is the coterminal of negative 42 degrees. Can the angle be more than 360, by the way? Sure can. You ever watch triad for the Olympics? Well, this is Summer Olympics, so what you might see, you're not going to see speed skating in it because that's Winter Olympics, but you might see people on BMX bicycles do a spin there. Or rollerblade, not rollerblade, what is it, skateboard. You see the person jumps and turns a couple of times, and you go, he just did a 720. Well, what the hell is a 720? What is a 1080 when they say somebody just did a 1080? Well, every rotation, every time you spin one complete circle, that's 360. So if somebody does a 720, isn't that 360 plus 360? That person jumped in the air like this, made one full turn, that's 360, and made another full turn before it came to a complete stop, did two turns. That's what 720. So you could have an angle more than 360 degrees. I can have an angle of 650 or 712. I go, what is a 712 degree? I don't know what that is, but let's see. It's positive, so you're going to go counterclockwise. You're going to start from here. You're going to spin one full cycle. That's what? 360. So if you subtract 360 from it, is that still more than 360? 712 minus 360, 352. Yes. You do more than one turn, Tom. So notice this one is 712. You did one complete cycle, which is what? 360. Now you're going to continue another 352. Well, 352, that means this is 90, this is 180, this is 270. Another 360, a little bit before that. So you're right here. That angle is 712 degree angle, which is the same as really as 352 degree angles. The same thing, except you have what? One extra spin in it. You did one full turn. In addition to that, you came back and did another 352. So if somebody just does 352 and wait for you, you guys gonna meet right here. So the 712 is one full turn here, revolution there. So that's equal to 1 full turn plus 352 more degrees. So you did 1 full turn, and the second time you stopped at 352. If somebody does a 1080, let's see what a 1080 might look like. Because I hear these numbers, 1080, 720, a lot in BMX racing, you know. You do 1 turn, that's 360. So if you take 1080 and you subtract from it 360, that leaves me with what? $180 minus 360 equals 1080 minus 360. It's 720. So the second time you're going to do what? Another turn. So now 720, subtract another 360 from it, and what do you have? 360. And on the third turn, what's going to happen to you? You're going to stop where you started from. You're going to end up back at the same spot, right here. So you did 3 full turns. That's what the person just did. Started pointing east, spun around 3 times and landed pointing east. That person just did a 1080. A couple more things in this section. In our book, this section is only 1 page. That's it. 1 sheet. But I want to make sure we cover all the pieces there. I'm spending a long time on it. A lot of times, especially if you're a machinist and you want to do actually fine measurement, you don't measure the angle in just degrees. You don't go, my angle is 18.6 degrees. They go, oh, that's not accurate enough. They use what we call DMS. What does DMS stands for? Anyone? Degrees, minutes, and seconds. On most calculators, there's a button that says DMS on it. I don't know if I can see on this one if it has DMS on it, but if I have a graphing calculator, I have a button that says DMS on it. How do you take an angle and change it from degrees to degrees, minutes, and seconds? Here's what you have to remember. 1 degree is equal to what? 60 minutes. And the way we write that, we go 1 degree equals 60. We put single slash, minute, apostrophe. 1 degree equals 60 minutes. 1 minute has how many seconds? 60 seconds. So 1 minute, single slash, equals 60, double quotation, 60 seconds. So double quotation means seconds. So when you say I have 18.6 degrees, we're saying, oh, no, that's not good for us. I need to write that in minutes and seconds. So here we go, 18.6 degrees. We know there is 18 degrees in it. But there's a portion of a degree, 0.6. We take the 0.6 and we multiply it by 60 because 1 degree equals how many seconds? 60. What's 0.6 times 60? That's 36 minutes. So it's 18 degrees, 36 minutes, and there are no seconds here, no remainder, 0 seconds. And that's the angle in DMS, degrees, minutes, and seconds. 18 degrees, 36 minutes, 0 seconds. So for really accuracy, you're going to see these machines have knobs on them, degrees, minutes, and seconds. You can adjust them to get the right or the precise value you're looking for. If you're cutting a piece of wood to doing carpentry in the house, if you're off by 1 degree, big deal. You go to Home Depot or Lowe's, you buy the stuff, it fills the crack there, you paint over it, nobody will know. But if that's a spaceship and you have a crack of 1 millimeter, that heat will go through it, will fry the astronauts inside that. So we need to make sure that we do precise cutting. Everything has to be just right. Let's try another one. 127.23 degrees. And I want to change it to DMS. I know there's 127 degrees already there. I need to know how many minutes and how many seconds. I'm going to take the decimal portion, which is 0.23, and multiply it by 60. .23 times 60. That's 13.8. minutes. I don't want to use 13.8 minutes, so I do have a 13 minutes. So now we have 127 degrees and 13 full minutes. What about the 0.8 minute? I don't want the 0.8, so that's 0.8 times 60 again. What's that, 48? So it's 127 degrees, 13 minutes, and 48 seconds. That will give me that 127.23 degrees on the money. How about the reverse, to go from DMS to degrees? Yes. We use that in machinery if you want to get a precise angle, because you can't really look at, when you look at, just like looking at this ruler, when you look at it, you go, I want to get, I don't know, let me just pick a scale here, something big enough. 3.27, you go, well, that's 3.1, that's 3.2. How do you get the 0.27? It's between 2 and 3 here, but where? So I can't really pinpoint that. I go, oh, somewhere maybe here, somewhere maybe here. So if you don't want somewhere maybe here, you want to get exactly where, we change it degrees, minutes, and seconds. Now, if someone gives you an angle in degrees, minutes, and second, I got 56 degrees, 42 minutes, and 22 seconds. Can you tell me how many degrees that is? I want to change it just to degrees. Well, it's the 56 plus, to change the 42 minutes now to degrees. Think of degrees like hours. To change 42 minutes to hours, what do? Divide by what? By 60, yes. Then you got to change the seconds to hours. How do you change seconds to hours? How many seconds in 1 hour? Can't be 60. 3,600? Because an hour has 60 minutes. Each minute has 60 seconds. 60 times 60, 3,600. So divide that by 3,600. And if you do the math the way you see it, if you have a decent calculator, 56 plus 42 divided by 60 plus 22 divided by 3,600, it's 56.7061111 repeats. Negative 115 degrees, 50 minutes, and 40 seconds. That negative is for all of them. That negative is just outside. The negative indicates you were going in that direction, clockwise. So here we go, a negative set of parentheses. 115 plus 50 over what? 60 plus 40 over what? 3,600. Here's the minus sign. 115 plus 50 divided by 60 plus 40 divided by 3,600. 115.844444 repeats. And that's how we go back and forth between degrees, minutes, and seconds, and degrees. I'll stop the video right here for this one.